Let's get started. David, let's have a really interesting conversation. Let's talk about architecture. Are you ready
Yeah,
for it?
I am ready to talk about architecture.
Awesome. So we're going to be covering what I think of as a functional architecture. So I'm going to step back. This is going to be big picture stuff. From my perspective, architecture is a definition of how software and data tools are organized uh, and for an enterprise such that they meet business requirements for the organization, and one uses design patterns and design principles to put those pieces of the puzzle together into that architecture. And you're going to see a diagram that really illustrates how everything comes together. Keep in mind, this conversation assumes some knowledge. We'll talk about the UNS Unified Namespace. We'll talk about the levels within manufacturing and some other terms and concepts. We're not going to get down to defining all these details. That's done in a lot of other videos, and we will be doing some other breakout videos on specific topics that we're going to cover here. So lots more conversations to come. Um, David, why don't you start sharing and give us a brief overview of what we're really talking about in this architecture? Then let's have a brief conversation about why, and then let's really dig in and have some fun here.
Yeah, so what I'm demonstrating here, and this is meant to represent the types of systems that you would expect to find within a manufacturing environment. And as you mentioned, this is high level. It's not meant to be a detailed idea. The purpose of and why I started creating this was ultimately to understand what types of systems exist in manufacturing, how that information is exchanged within the various systems, and then equally important, how that information is persisted. Because as we know, people are always trying to look for this real-time information. Well, you need to understand the cause or the source of that information and how you need to consume that information. So all of this plays into that. So, understand as we walk through this, this is really just meant to demonstrate those three things of what systems are here, how does that information get exchanged, and how is that information persisted? How do we store it? What does that look like?
And so the purpose of this kind of solution that you would put together using this architecture is essentially to get value from the data. I mean, that's all of
Yeah.
what we do as an organization. So get value from the data, enable connecting all the systems across the plant, enable visibility into yesterday, today, and tomorrow. Yesterday for data around root cause analysis, what happened? Let's dig into the details, or how did we perform? Today, let's get visibility so we can tackle problems faster and change behaviors of people in the plant to enable them to do better, and also for tomorrow to be able to use that historical data and project, forecast, predict what's going to go on using all those new fun technologies that are coming out. But why should a CIO care? Why
So
why
it,
do
it
they really
yeah,
care?
Yeah, I mean, it comes back to the idea that we want information, we want data, and depending on what group of people that we're talking with in a manufacturing environment, so I'll start off with, the proverbial OT group, which they're more involved in this. As you're looking at the diagram, that level three, level two, level one area, the operational side, the manufacturing side, how they view data and how they consume data, especially when you get into time series data. This is going to be that on that level two, that historian, the raw time series, is very different than maybe how an IT group looks at particular data. They're more familiar with either column or row oriented information. And as I mentioned, depending on what group I'm talking to, there seems to be a misunderstanding of what types of data exist and how it wants to be consumed. So the reason why how data gets persisted is so important is because it's going to depend on how it is that we want to consume it. So this helps the CIO of a company realizing that we want to do something with our data. We need to get and extract more value out of that. But before you can do it, you need to understand, where is this data coming from? How is it stored? And then how do I optimize it for depending on the use case and that type of thing. So you'll notice in these white squares that are sitting on the right side of the diagram, this is how that information gets consumed. And depending on what it is you're trying to do with it, that will then indicate how you need to get the data there in the first place.
And connecting with that idea around the CIO, and why do they care, and what you've talked about, one of the things that we should clarify is a lot of manufacturers, and I mean a lot of manufacturers, are looking at this and thinking, wow, wouldn't that be beautiful? I would love to create that kind of setup. What their current problem is that they are riddled with technical debt and trying to connect everything and get value out of the data. They've got a lot of proprietary solutions that don't allow or make it very difficult to connect the multiple systems or try to do all that connection just within their tool, and it just doesn't work well.
Mhm.
And also, those companies have data silos that are in specific digital technologies as well as in lots of little spreadsheets and pieces of paper floating around the company. And you can't connect all the data together and get value from it, which is what the CIO is really trying to do for the COO
Mhm.
and CEO. So they want to be able to connect it all together. And what we're enabling, or what we're doing here, is using non-proprietary concepts and technologies, open standards for doing this, and then yeah, I guess it's pretty much just those kinds of ideas uh, to be able to put an architecture together like this.
Yeah, I
So
mean, so yeah, I mean, what you're getting at here is that we want to connect our intelligence, and that's what all of these
yes,
database diagrams look like, is integrate our intelligence through a common technology, not into systems and solutions. So as we dig into the details of what do I mean by these various exchange, you're going to see that there is it's a technology. There's nothing specific about what it is we're trying to do. We want to integrate through that abstraction layer, if you will, through these various exchange mechanisms.
okay, good. All right, with all that warm up and preparation for why we should
Yeah.
care about what we're going to see, let's get into it.
Yeah. So just real fast as we start breaking this down, and this is sort of like, think of the British Bake Off show where this is the finished product. This is where we're going to get. I'm going to walk through what each of these pieces mean. I just want to reinforce this is not meant to be an overarching technical deep architecture. It's only meant to demonstrate these are the systems, how information is exchanged, how information is persisted. So let's get at it. So the first thing we want to focus on is the master data model. And people who have done ERP and database implementations are going to be very familiar with the master data model. Depending on the use case or the nature of the business, we want to construct the overall database schema utilizing some sort of a common schema and modeling all that information, all that data through what is affectionately known as the master data model. Now, I want to extend that concept to all the other systems that are part of our manufacturing process. And this can be, again, it's going to speak to the ERP, but you also want to think about how are we organizing all of our information within the MES. And because we're our practitioners of the ISA 95 standard, this is something that specifically is where we're going to have the equipment model is going to reside. And then, of course, all of the resource models that are associated with the information that's going to be exchanged. So the first thing you do is always start with a good plan it before you start doing anything, and that all needs to be through that master data model itself so that all the other systems are going to be able to consume it. This is very important, especially when you get into this unified namespace concept, is that we want to start modeling that information through a common standard. Now, it doesn't have to apply to a formal standard, but what I'm getting at is that regardless of what the equipment is and how it's going to be exchanged or what it's doing, try to come up with, sometimes it's known as the data dictionary, but everything is going to be utilizing the same type of common data structure.
Are you referring to or thinking about the semantic hierarchy that we typically use from ISA 95 Part 1?
Yeah,
Uh, o-
yeah,
okay,
the enterprise site area, work center, work unit, that's part of it. That's that topic of exchange, but then also the models themselves. So if I want to model
okay,
an asset, a pump, a compressor, a
okay,
motor, I mean, it's
great.
everybody knows me as Mr. Compressor because that's generally my asset model that I reference. But yeah, that's the type of thing that we want to have as part of our master data model.
Okay, awesome.
Perfect. So moving along to familiar territory, this is where we're going to get into the ERP. That's your enterprise resource planning. And I guess I should just clarify real fast, the levels that you see here on the left, those are referencing again, the ISA 95 standard, where you have your level 1, that's the control area. Level 2 is SCADA. Level 3 is your manufacturing operations management domain. And then finally, level 4, those are going to be all your enterprise business systems. So I just wanted to point that out and clarify for people that are wondering. Most of our audience is quite familiar with this, but as we attract new people, then we certainly want to start with the basics there. So ERP, it's enterprise resource planning, and this is what it started off as your accounting, your cash, the way that you accounted for, the money that you had in the bank, what money was spent, what money was, what income came in. But ERP does a lot of that, planning of what it is that we're going to offer, when we're going to make it, how we're going to make it, those types of things. But it's a very high level. It doesn't get into a lot of the details of how we're specifically going to do it, but as I mentioned earlier, that master data model will it will inform how it is that we're going to build the ERP. It's also important to notice that this is a row-based type system, so the database schema that's associated with an ERP, because it is transactional in nature, it is going to use row-based to make it very easy for other systems to query that information. Now, most of the time you'll expose it through an API, but that's going to be the underlying data set typically. I did want to point out the connectivity here. It does reference API. Understand that the ERP is probably not going to hit your master data model with an API, but there are other systems that may want to use an API to do that. It could also be just, as I mentioned earlier, a document dictionary, but the idea, if you want to have automatic exchange of information, the ideal situation there is to bring that through a master data model. But ERP, I think it's fairly well understood, but I think just wanted to point out for the purposes of this conversation that ERPs are generally a row-based data set, and you can query it with SQL tools, although it's more common to use an API for that.
Yep, good.
So moving along here, we'll get into the exchange. Now, I want to be very clear that the exchange is not meant to demonstrate, let's say an MQTT broker or something along those lines, although a broker is likely going to be part of that exchange. Think of this more like it could be a microservice or something that is hitting that ERP with an API call, and then it's going to be modeling the information that's going to be exchanged through something. So could be a microservice, could be some Python scripting or some .NET scripting, could be using an MQTT broker in there. There's a lot of ways to do it. The thing to think about and pay attention to here is that we're going to start exchanging information. This is that integrate your intelligence through technology, which is going to be that common technology of how we want to move that information around. And that's really how you want to look at that exchange. But if you do, just for simplicity, want to say, oh yeah, that's a broker, then that's fine as well. Just understanding that your ERP is probably not going to support whatever that broker is, like MQTT. You'll need something there to get the data out, but that's okay. Again, can't emphasize enough, the purpose is we're going to make it easy for information to be exchanged with other systems in a common standardized way.
Okay, then what are we exchanging the data with? What's next?
All right, so now this is where we're going to start getting into the level 3. This is now getting into that manufacturing domain of your manufacturing operations management, and oftentimes it's known as a manufacturing execution system. So to maintain good cybersecurity posture, oftentimes you're going to have these two exchange type systems. They will exchange information between themselves. Keep in mind that this all could be one big holistic architecture as well. We've all seen many of the diagrams of the unified namespace where all of these systems are connected. It could be, although more often than not, you're going to find different types of exchange mechanisms that's getting the data and information ready to go prior to moving it up or down within your overall technology stack. So when we get into level 3, again, this is going to be your manufacturing execution system. There are, within the ISA 95 standard, there are 12 functionalities that exist within there. Most people are familiar with MES, through what's known as the Core 4, and that's, I think, because MES has largely been sold and marketed through some sort of functionality, whether it's OE downtime or material genealogy, track and trace, whether that's a statistical process control. Those are the types of functions that you're going to find in an MES. Again, because this is transactional information, more often than not, most of the MES on the market are going to use a row-based, there's going to be a database schema with row-based. Something that's new is using knowledge graphs for MES, because you get into a lot of complexity. within your MES, and oftentimes you just don't have the ability to do all of the, define all those relationships through these primary and foreign keys that are very common within these row-based, like a SQL type database. So there are other mechanisms or other tools that are there. Knowledge graphs are becoming a lot more common within manufacturing, but oftentimes, especially within your MES solutions, if it comes with graph, especially if it's got a defined relationship. I mean, you'll have a schema, but if there's some sort of ontology that's associated with that, then that becomes a very good way to handle your MES. The way that you're going to exchange this information is through something called B2MML. Now, the business to machine markup language, or to manufacturing markup language, that was developed a number of years ago. It does use XML, which was not as easy for other systems to use. It's now been refactored that it does have JSON data structures with it, so it's much more easy to integrate and exchange information using like HTTP requests. That's pretty common. But how we're going to get information between our level 4 systems and our level 3 systems is going to be using this concept known as the B2MML. And so that's, again, it's just a standard schema for exchanging that information. So coming down, we're going to use B2MML.
A couple questions. So at this point, to kind of set the picture, back up a little bit, you had said starting with the master data model, we're going to understand how the plant is organized semantically, enterprise center, or enterprise site, area, work center, work cell, and also looking at the specific models for much of the equipment and the assets. With that said, then the ERP should already be consuming and using that kind of structure. That's where usually where the master data model is defined first, but then you're communicating that into the exchange of the data. So where that data is exchanged within that structure. And then also, now that we've come down into level 3, you're still continuing this concept, this idea of that master data model, the structure of the data and the models of the assets and equipment into the MES as well. Is that fair?
Yeah, absolutely. So again, going to referencing ISA 95, you'll find that I just can't say that term enough. I get paid a quarter for every time I use it. Is that the master data model is going to inform your resource models there. It's going to be your materials, your equipment, your physical assets, and your personnel. It'll also have the processes in there. This is how we actually go about making it, and the master data of what does our routing look like, that type of information. That's all going to be in the master data model, so that we understand fundamentally how do we actually make things in this operation. What does that all look like? So master data model is going to heavily inform that MES, the database, or how you're going to go about configuring that information. And again, we like to use the word ontology. It's a description of everything that's associated with it, and that's really, especially when you get into these graph type databases, that's really where we're going to spend some time.
So at the risk of making this video maybe a little bit too long, we'll cover these topics more deeply in other videos, but why pick a standard like B2MML?
Yeah, absolutely. And just a real simple answer is that if we all agree on the standard of how we're going to exchange information, that anything that we want to, any intelligence that we want to connect, as long as we exchange that information in a common payload that we've all agreed to, makes it very easy to, anybody can solve a problem. Can I scale and extend that solution that I've developed? And utilizing standard payloads allow you to do that.
Yeah, and we're in the middle of some projects with some pretty darn large organizations doing exactly that. And that's why they are adopting this. Attempted to do it on their own, weren't using some standards to the level that really made sense. And so, we're picking it up and moving from there.
Yeah, absolutely.
If in this next exchange or next level, it would be good to, you might be covering batch ML too. I want to make sure we touch on that.
Oh yeah, absolutely. Yeah. So
Okay.
B2MML is meant to be level 4 to level 3, or level 3 to level 3, depending, because you're manufacturing, your mom domain, manufacturing operations management. There's a lot of, you could have different systems that are performing that function. A very common one that sits off by itself is your CMMS, your computerized maintenance management system. That'll be there as well. But that's the intent of, it's your level. It's the part 2 exchanges and part 4 exchanges is what's there.
is worth mentioning again, deeper coverage later, is in thinking about these exchanges and using B2 MML between levels 3 and 4, and also within 3, is the idea that we want to do data validation, and make sure that the data got there, make sure that the data is complete, et cetera, because we can't just trust an MQTT data broker. We can only verify that it got to the broker itself or from the broker to the destination, but not the whole way through. So
Mhm.
there are some concepts, feel free to touch on them just briefly, so that knows, that there's something more there that we need to dig into.
Yeah, so within that exchange, that's also going to have that schema validation to ensure that the data payload that's being exchanged has been properly formed. We're going to do data validation, meaning that the information that's been presented in that payload is it's correct and it's proper. So, a good example of that is if my ERP says I need you to make, a particular material definition, material ID or product code as it's generically referred to. Well, I'm going to validate, does this product code actually exist in my MES? Do I know what this is? And if I don't, then it's going to reject the information and it'll give you some sort of an error handling response. And then, of course, it's data validation, schema validation, and you're going to now have the acknowledgement. So, this isn't meant to serve as a video of how you utilize B2MML, but there
Yeah,
is a
yeah,
setting in there that says, do you need exchange? Do you need acknowledgement of this particular payload? Again, you can utilize it whether it's a push, a pull, or just a pub sub. It has mechanisms for doing all that. So those are the pieces that are there.
yeah. To highlight the value of it, and then again we'll break it out later in some other video. Is the way I like to think of it is if an order is coming from level 4 to level 3, you want to make sure that that order was received and acknowledged. Otherwise,
Mhm.
either the order is not going to, the order might not be made because they didn't know that an
Yeah.
order, in the plant, they didn't know an order was sent, or if that order was sent twice by accident, by the technology, you don't want to make two orders,
Yeah, absolutely.
because that would also be almost as bad.
Yeah, yeah. When I
So
worked at at Pizza Hut in college, every now and again we'd make the same order twice because we didn't have a good workflow of the tickets in the kitchen. So, oops, that'll happen.
but if we're making big ingots or big machines, that's a little bit more expensive than just an
Yeah,
extra
yeah,
pizza.
it can be a pricey mistake for sure. So absolutely, yeah, there's a lot more that to unpack within the exchange area there and how that information flows. So
Yep.
all
Yep.
right. Yeah, so let's dig into level 2. So again, we're going to have this exchange mechanism between your level 3 and your level 2 systems. And this is where we get into the SCADA, that's your supervisory control and data acquisition. Now we're into this visualization piece where we're going to be historizing data. And as the name would suggest, it's the overall supervisory control. I think people are fairly familiar with what SCADA does, but it's generally the pictures that are on your screen. It's the operators, it could be level, or it could be an HMI that sits there, but this is that level 1, level 2 domain. It's the actual human machine interface for people to look at what's happening. It's the visualization layer, if you will, of the actual manufacturing process. So the exchange between your level 3 and your level 2 is now going to use another part of the standard that was developed by Mesa, which is called BatchML. And that is it's a markup language between your level 3 and your level 2 systems. And it has some very specific payloads to it. Keep in mind that BatchML was written around the ISA 88 standard. So there's going to be a lot of terminology and properties of that payload that are going to be very specific to that ISA 88 standard. Keep in mind that you don't have to use all of the properties within a payload. You take what you need, and there's certain properties that are required, but BatchML, again, it was written around that standard, but you can use it generically for any type of process. The point here is that we're going to standardize the payload and how we're going to exchange that information between those. Once you get into the level 2, this is where you're going to start seeing a lot more of this unified namespace or UNS type data. Going back to your master data model, when you start building in your UDTs, your user-defined types within your SCADA system, and even in your level 1 system, your master data model is going to help you define what do those look like, how do we want to model our assets, how do we want to develop our equipment hierarchy. So you referenced earlier the ISA 95 Part 1. What does all that look like? The reason why we want to start doing those types of things is so now we can implement a unified namespace. The idea is we now have commonized and standardized on how that information from an equipment perspective looks like, even though, batch and B2 MML, those handle those common specifications, it's not as defined within this UNS space. There was a post here recently, where I commented the best part of the UNS is that there's not a standard. The worst part of the UNS is there's not a standard. Well, you can develop your own standard enterprise-wide within that, but it's very important because UNS gives you a couple things, of course, and it's an event-driven architecture, which is quite novel for that level 1, level 2 area, but we're also going to have these data models that now can be readily consumed by other systems. Going back to what you asked, why would a CIO care? Well, it makes it a lot easier that we can start comparing like for like if we know what that data model coming from our even level 1, level 2 systems is.
And again, that data model is coming from the master data model. It all starts there, and that's why you say start there.
Awesome. Yeah, absolutely. And now this is where we're going to start talking about this API, because if your SCADA system has the ability to interrogate the master data model and what does this look like, and it can then parse that information coming through and dynamically build we'll just call it the tag structure, that is going to enforce that anytime there's a change up here, that's going to be reflected within our system as well. And that means that we now have data governance that's associated with what it is we're trying to do. With the caveat is that it does allow some flexibility. So the governance will be, you have to do this. The innovation is that you can also extend it, but at a minimum, it needs to have that. But the master data model is going to inform that.
Awesome.
Cool.
Next.
And we're going to get all the way down to level 1. And so we'll just get into the controls layer itself. Now, within controls, I'm a big believer in that the operation, the purpose of your level 1, we'll just call it a PLC or your DCS, that is the safe operation of the plant or process. Fundamentally, every decision made at your control layer should be to that end. That is somewhat of a broad statement, but that is really why it is that we are, or how you want to think about what it is we're going to do for controls. Tag naming, that always is problematic. How do we standardize on what these things look like? And unfortunately, it is all over the map because you have so many people that have their own styles of how they go about doing it. So long as it meets safe operation, I'm not as concerned about what those tag names are. So yes, it'd be great if there's some master data that's associated with how we go about naming things, and there are more mature organizations that are better at it than others. I don't get as concerned about it, but if you have the ability to extract that information utilizing this unified namespace capability, then that would be ideal, so that the things that we're naming, the things that we're exchanging there, it's if we can model right at the edge, right at the plant floor, right at our controls layer, it makes it so much easier to integrate it at the rest of the manufacturing systems.
Fantastic. Let's keep going.
Cool. So now that we have taken all of our data, we've modeled, and we have really good architecture and really good design and governance from our level 4 down to our level 1. Now we need to start getting that information back so that people can start consuming that information. So where you're typically going to find that first set of level 2 SCADA, it's that data acquisition piece, is now we want to have some sort of time series database, or a process historian as it's generally known. So in this case, because we've done a great job of modeling data in our SCADA system and in our control system, it's going to make it so much easier for your process historian to consume that data that's already modeled. So now if you want to use a product that allows you to do these, to consume those asset models very quickly and easily, if you've predefined it, you've modeled everything, it becomes so much faster for you to start gaining insights and building the information right through that as well. So a couple things about the historian. It's raw time series. This is going to be a very specific column-based type data set that you'll see inside, or within the process historian itself, because we're constantly moving. The domain is time, so you're going to see that information being ingested into that more column-based type approach. And then, of course, the way that you are generally consuming that information is through some kind of trend screen that is existing within your SCADA and or your HMI. But all of this information exchanged utilizing a unified namespace type data model, especially when you get into trending or, and developing these objects on a screen. If you've been able to identify, and utilize these data models, it makes it very easy to populate and extend screens so that if you've added in additional equipment that meets the master data model, those screens can be dynamically rendered. Those tags can be dynamically consumed. You and I did some videos on that here a few years ago. But
Yep.
that's the idea here, is that makes it, if you follow that domain in knowledge and you've exchanged the information properly, you're going to be very readily and able to consume that information right away. But
And again, it gets
yeah.
back to the data models. The master data starts there.
Yeah, exactly.
It's
And
a huge,
level
powerful
two,
piece of this.
100%. Yeah. And keep in mind, this is where you're going to have your raw time series data. This is that high fidelity data. This is, where you're going to be getting into that, 1 second or even, faster. Sometimes people get into this 20 millisecond type range, understanding that's a specific use case, but that's where that type of information is going to exist. So now we're going to bring things back into level 3, because there are systems that are going to want to consume that information. It's an idea that, especially if you're utilizing, depending on your cybersecurity posture, you may not want your level 4 system connecting into your level 2 systems, although there's really no reason why you couldn't do those types of things. It does give you a nice, from a cybersecurity standpoint, keeping these things separate. It's not a bad idea for sure. So what we want to do at level 3 is we now want to start aggregating some of that time series data or downsampling some of that data. So as I mentioned earlier, we're going to have that, 1 second data or, even 500 millisecond type data that's going to sit in that, that raw time series historian. We may want to have a 10-second sample rate, or even something slower, depending on the application that is sitting in this level 3 area that is going to be used by other systems. And the reason why we do that, especially if you're putting more and more information into a cloud infrastructure, is that that data can get very expensive if you're putting in and doing all those writes. So that's one aspect of it. And if you have that high fidelity data that's being stored there, it also gets to be very expensive to keep that information. So the idea is that people that are sitting maybe at that business level, that level 4, they may want to be able to see some trend screens. Well, the trend screens that are going to exist in this aggregated time series, more often than not, is going to have the fidelity and the resolution of the data that they need. And it makes it for a less expensive way to both ingest that information as well as store that information. Again, historian, it's going to be specialized column-based, and we're going to utilize unified namespace type models to exchange this information.
One quick pause to bring up something that you and I have experienced. So we were on a call with I think it was on the OT, no, he was on the IT side at a high level in corporate, and he started to bring up a question around where the historians were physically located, physically hosted. So simply want to use that situation, which you might remember, to remind everybody this isn't as much a conversation or an illustration around where the technology solutions and the data are hosted, but rather from a functional perspective. He was saying,
absolutely.
I've got all this data hosted on the plant, but gee whiz, don't have too many IT resources in this plant to be able to run and maintain that time series database of that process historian there in the plant. So can we run it in the cloud? And one of your comments was things can get very expensive when you're running it in the cloud because of the transitioning, the bandwidth, the data moving up into the cloud itself, let alone the hosting. And he was asking a good, valid question, a thing that they're concerned about, but he was asking it in relation to this diagram, and this diagram doesn't really discuss or define any of that kind of concept, right?
Yeah, absolutely. It would be somewhat out of scope for this. So if we wanted to
Yep.
take this and then build a proper architecture that also included where I'm actually physically locating those types of things, again,
Yes.
these levels here are functional. It's not meant to be a
Yes.
network type architecture. And it's a good idea, at least for your transactional information, so that your mom domain, that there be some set of that exists on the plant floor only from an internet connectivity standpoint. So, interesting since you brought this up. As I would say, about 5 years ago, the pervasive thinking was we're going to be, cloud native, cloud only, and we're going to
Yeah.
take as little on site and we're going to put it in the cloud. And I think what drove some of that is because, well, that got pretty expensive. And they realized that their connectivity wasn't always as good as it could have been. So, ideally, level 3, especially if you're cloud first, cloud native, put a subset up there. It'll be a lot less expensive. But that level 3 can also exist at a manufacturing location as well. It just depends on where you want to store that data and how it wants to be consumed. That's really the intent here is how do we want to consume this information and how do we want to think about it?
Great. Awesome. Next.
Cool. So now we're going to get into what a lot of people are familiar with, and this is the data lake itself. Very common that people will want to take information from level 1, level 2, and they're going to dump it right into a data lake. And we run into this a lot, and that's fantastic. That's a great way to use the data. So similar to how a time series database is a specialized column-oriented database, your data lake is also a column-oriented type database. Going back to this concept of a unified namespace, what we've done is we've added intelligence as we've integrated this information, starting with just basic asset models that are controls. We've now added in some more, some higher level more details at the SCADA level. We've also introduced things that are coming from our manufacturing execution system and or our ERP. So we've added that context of not only our time domain type information, that SCADA data, telemetry information. We also know what product code am I running? What is the what's this work order or this, the production order from the ERP? What is that? Who's doing this type of work? Along with all the other information that's there. Well, once we start contextualizing that information, we can put it into a data lake. It is meant to be unstructured data, but in its raw form, that's where you can start doing a lot of your AI and your ML, because you're looking for patterns of data that exist within a time domain. And that's perfect. That's exactly what's coming all the way from your plant floor. It's your time, your TVQs, your time, your values, and your quality. And you aggregate that information, you contextualize that information utilizing these data ops tools, and then that all gets dumped into a data lake where you can now start looking for likes. But it's also going to be column oriented, and the typical applications are going to be for your AI ML. And then if there's results that come from that, you can always present that back down through your UNS as well, that it's consumed down at the plant floor itself.
A couple of thoughts. One is around the data, some clarification, something that we talk about a lot with companies that we work with, and you and I talk about a lot as well, is data models. Data lakes, some people, some companies treat that as just kind of a dump. Okay, I'm just going to dump the data in there, and then some poor data scientist is going to have to clean it up later and figure out, model the data, contextualize it, et cetera. And what we really try to do is to, just like you started this whole conversation, let's define the data models, the master data model and the models of the assets, and let's clarify, get good, consistent data models for those assets and the equipment in levels 1 and 2, get it at level 2, and then communicate that all the way up to the data lake, so that at that point, data is already modeled, data is already clean, data is already contextualized. So there is some unstructured data, but a lot of it really should be structured as well. Just a kind of a point to clarify for people, something we talk about a lot.
Yeah, absolutely. And that's, we used to talk about this ETL, this extract, transform, load was very common, 10 years. I mean, it's still common, but that was really sort of the only way to do it before. Well, now we have better thoughts around how do we want to do these types of things. And that's, again, speaking to the power of a unified namespace of the master data model isn't just for the enterprise, it's for everything. And it also allows us for these exchange mechanisms. If we can do that, in an event driven, this pub sub, this, MQTT and or Sparkplug, those are a quick way to get it. But, the point is it's already structured. So when it lands in your data lake, even though it's unstructured data, the more structure we can get to it, the faster it is we can start realizing value with it.
Another question too, and this is where it's hard to think strictly and only in functional terms. Technology concepts come up. You're even just bringing some of them up here. And I want to address the use of UNS in some of these communications where it goes all the way up to the data lake. So typically when we're thinking about level 2, UNS makes sense. And you and I agree, UNS is primarily a level 2 construct. So MQTT Sparkplug B works really well, applying some certain technologies. But you have UNS going up from level 3, or actually from level 4 to level 3, and also you have it in level 4 between the exchange and data lake. Does that imply or does that mean that we are actually using MQTT for it, or is there another concept you're conveying by saying, hey, we're exchanging data with the data lake using UNS?
All it's meant to say is this is going to be the structure of that information that's being exchanged. So at this point, it's Sparkplug, since you mentioned that, or I guess I brought it up, is really more of this level 1, level 2. This is where you're going to use Sparkplug. At this point, you're going to start creating these large JSON structures that are then going to be ingested by that data lake itself.
Yes.
So what I'm getting at is UNS, it's telemetry, it's time series, it's contextualized, it's not just your process historian data. But yes, the structure of that information is going to follow that unified namespace concept where your topic structure is going to follow that ISA 95 hierarchy or equipment hierarchy model along with it. But it will be, it could be MQTT. You can use AMQP. You can use DMP3, although that's, I only run into that in Power and very much Power controls. But, the point is that it's a common technology. It's not a bespoke point-to-point integration.
Yep. Okay, good. Next.
All right, and then coming full circle all the way back to the beginning of this, now we're going to get into the data warehouse. So what a data warehouse is it's row-based, but it gives me the ability to query it with common query tools, whether that be Power BI or standard SQL queries. But the idea is that we've taken this this raw, this unstructured data, if you will, and coming back to this whole exchange mechanism is that I'm going to have something, there's going to be these processes that run that take this information, the raw unstructured data in our data lake, and it's going to present that information into the data warehouse itself. And this now gives it to some immediate queryability to where what's happening, and this is where a lot of companies spend a lot of time and energy, is how do we get information from the data lake and get it into a way that I can readily consume? Again, it's these processes that are running, but the idea is that I'm taking raw and structured, I'm cleaning it, I'm giving it to some sort of format, and now I'm presenting it in my data warehouse that makes it very easy for people to consume through standard query type applications. Your data warehouse is going to be row-based. And I do have some UNS type information that is being consumed there. But it could be information that is now coming from my data lake. It's the result of an exchange. But the reason why I use UNS here is that you're also going to have other systems that might be looking at this aggregated or even this raw time series data, and we're now starting to put some analytics around it. So this is where I'm going to utilize a term that's not as pervasive in the market, but it's this unified analytics framework. It means that the information that I'm going to find in this this row-based technology, and it could be it's a SQL query or it could be some sort of API that I've already defined what is the information that is available here. So we're coming all the way full circle of the master data model. That unified analytics framework gives me the ability I can get at aggregated data, contextualized data, that's also going to have some events and some transaction type information there. So classic example is, what was my maximum temperature during this particular batch operation? Or, what were the time in the beginning and the end of this downtime event that existed within within a manufacturing process? So what this allows you to do is take a lot of this information and look at it together, but it becomes row-based, very easy to query. It's a unified analytics framework. It now tells me these are this is the information that's most important to you and how you want to put it together. So, very high level, generic, view of what's happening there, but That's why I just have this as being this more UNS type information is it's going to be consuming both. It's either going to be the result of this a routine that's running somewhere in an exchange, getting data lake and dumping it into this data warehouse, or it's going to be something that is consuming time series data along with some MES type data, and then presenting that in a mechanism to where it's a common view of the information that we can now present for other stakeholders within the business.
So good. All right. Well, I think we're at the point of starting to wrap up. Any final thoughts? I'm going to kind of summarize some of the concepts here, but any remaining thoughts you have around this?
Yeah, all I'm going to get at is create a master data model and then utilize a common method for some of the exchange of the information. If you can use a standard, great. Or if not, then come up with your own, but be consistent all the way through. Because once you've developed that and you've defined it, put governance around it, along with some rules of engagement, makes it so much easier to do the rest of the information. Coming back to what you said, why would a CIO care? Because they want the right information at the right time in the right format to the right people in the right format. It makes it much easier to get it all right in the right format if you've done all this hard work up front.
I was going to summarize all that. You just took it all. Awesome.
Sorry.
Perfect.
Didn't mean to steal your thunder, Kevin.
It's all good. Future videos will break down some aspects of this more. There are a lot of other topics that kind of play into this, including data governance, rules of engagement for projects and how to execute those, strategy, change management, how to scale from one pilot project to other projects within the plant, to extend and to scale within the plant. And then a really interesting thing we're finding that a lot of companies are struggling with is then how to scale across the enterprise. And again, we get into a lot of these. There are some principles and best practices and strategies, rules of engagement, and all these kinds of things that apply at the enterprise level as well. And there's going to be a lot of videos. So
yeah,
a lot of good stuff.
And we're going to get into the weeds a little bit too technically and demonstrate how we utilize some of this technology and how do I go about solving problems with different tools that are out there that sit at different layers. So
yeah, but for me, this is a really good video to say this is the starting place. This is where it all happens from a functional perspective. Then we're going to be talking about implementing and reviewing and getting into technologies for all the various pieces of this architecture. So this is almost kind of like the foundation, as I think of it. It's a really good starting point.
Yeah.